Curtis? I'm Curtis. Oh, okay, great. Thank you. All right, we're going to get started. Welcome, everyone, to IETF 126 GAIA. The back clock seems to not be working or whatever, but it's actually 9 o'clock. So we're going to get started. So just as our normal introductions, we have the note well and the general participation stuff. It's Thursday. If you're a bad actor, you've probably been kicked out by now. So, but we still have to post this. I think, imagine everything is fine. Everyone sign into the Meet Echo. There's stuff going on online there, actively discussion and the like. That's going to be a little out of bound. And then sort of the resources for the general event. But the big thing of note is, of course, our agenda here, which is somewhat packed, actually. Normally, we shoot for 3 to 4 speakers, but lots of interest here in Vienna, and an ongoing RFC, which we would appreciate some feedback on. So I think as discussion with the other speakers, we were going to start with Leonardo, then Marcelo, then myself, Leandro, and Steve. And everyone gets 20 minutes, roughly, which should be 15 minutes of talk, 5 minutes of questions. I don't think we've aligned the clock thing in Meet Echo to this, so you won't get any warning aside from me sort of side-eyeing you up at the front. So all set, let's get going. Well, I should say welcome from me. I'm Curtis Heimerall. I'm one of the co-chairs along with Adisorn and Jane. Adisorn's online and we'll be sort of helping out from there. So let's get Leonardo's slides up. And then give this guy slide control. And I think you should be good.
Yeah. So thank you. So I'm going to present this paper, just a little bit of introduction about myself. I'm an associate at Ca' Foscari University of Venice in Italy. And I've been working in the past on community networks, specifically in a big project, European project, also with Leandro here, that was called Net Commons, which we were dealing and working on, and with community networks. And this is a review of work done with Joran Serdalaben from UPC in Barcelona, and Gabriele Gemmi, that was a PhD student of us, of both at the time, and now he's at Northeastern. So what, well, a table of content introduction, what kind of data set we use, what is the way we design this wireless backhaul, modeling the cost, and then results. So before that, actually, why? So what we wanted to do with this paper was to estimate the cost of a mesh-based wireless distribution backhaul system based on realistic constraints. So the question we were asking is, we want to make a network there where there could be nothing, and we want to know how much this mesh-based backhaul could cost compared with the alternatives in that area. And so now I'm here. This is a paper that was published 1 year ago. I'm here because I would like to collect feedback, understand if there is something that you think we did well or we didn't do well, what are the parameters we should change or use, and encourage and discourage us to go on with this work, because it's time consuming. We all have to keep alive the data, and it's not easy. There are way too many details to report here. They're in the paper, and we can discuss them and share them offline. So I'm just going to give you an introduction and an overview. So the ingredients here, a practical strategy to design a wireless backbone with point-to-point point-to-point or point-to-multipoint wireless links. We don't claim any optimality here. We just take a problem and we try to solve it in a practical way. An associated cost model, which we derive from public information, and enough real-world data so that we can do Monte Carlo simulations and try to understand, try to give some robustness to our results. So we start with this assumption here, okay? You have a set V of locations that you want to connect, and ideally you know what are the line of sight link between those locations, and you know where there is a point of presence of an ISP, which you can use to achieve connectivity to the internet. And you have a certain idea of what is the capacity you want to provide to every subscriber household, and then the problem here is how you design your network. So first, the data set. This is coming from other works that we have been doing in the past. We took 10 municipalities in the center of Italy, from which we have the land shape and the building shape. So in the end, we end up with a 3D model of the whole place with buildings and their size and shape. This is just like an idea. This is a urban area, but it's just to let you see what we have. And then for every building, well, those areas there have really bad connectivity. They are generally underserved. The best thing that they had at the time was an XDSL and Starlink. And the idea is that once you know where the buildings are, then you use GPUs to compute the line of sight. So what you're gonna have, it's this graph here that tells you where your subscribers could be and what are the wireless links that you can actually have in that specific place. And then what we do is we retrieve the population and the household numbers from the Italian Statistical Institute, which well, this is some average data of those areas. We set the subscriber ratio, so we say, okay, let's assume that 25% or 50% or 100% of the people there are going to be part of the network. And then we can associate a certain probability P that in a certain building we have a subscriber. And that's the way we perform simulation. So we can actually extract random choices of the subscribers. So we don't have one single network, but we can try to generalize our results with some statistical confidence. In this case, we do 30 runs. So that's how we get the data initially. Then how do we design the backhaul? Well, we start from some assumption on the wireless nodes. This is a typical configuration that we have been working on and with a community network for a very long time. So outside you have a pole with wireless point-to-point and point-to-multipoint devices. And then inside the house, you're going to have the router that powers everything and does the management. So here you're going to have the routing protocol, and then you're going to have an access point at home. We use two frequencies, 5 gigahertz 11AC and 7 gigahertz 11AD, and we collected a lot of data from vendors, and we used state-of-the-art path loss model to compute the link capacity as a function of the distance. So ideally, we could compute this and understand what is the capacity of a certain link, given that we're using a certain device, which could be a Ubiquiti or Microtic or whatever kind of device that we were surveying at the time. Then what do we do? So we have this more or less large area, and we want to bring connectivity there. The first thing we do is we split the area in clusters. So we use a clustering algorithm that takes this graph here, well, the graph that I mentioned before, again, this graph here, a subgraph of this on which we extract our subscribers. And once we have this visibility graph of the region that we want to cover, then we are going to cluster it because we don't want to have a big mesh with everybody inside it. And then inside the cluster, we are going to choose one node as the gateway, and we are choosing the one that is more central in the topology of the cluster. And then we are going to build the minimum distribution tree rooted at the gateway to reach all the nodes. And so in the end, we're going to have one gateway, some leaf nodes, and some of what we call relays that are nodes with more than one link. We actually make the core network, that is the network of relays and gateway, to edge connected, so it's resistant to a failure of one edge. We have completely another paper that just deals with the robustness of the network, but so I'm not going to touch over this topic here. And then we take the what we assign a capacity to the customers, so to the subscribers, and then we dimension the links, which means we choose the devices, which could be point-to-point, point-to-multipoint, and if necessary, we even double the link. We add links to have more capacity so that every subscriber has the guaranteed capacity that we want to provide. And then from the gateway here, we compute the shortest street path, like on the OpenStreetMap map, to go from the gateway to the point of presence of an ISP that it's in the area, which we estimate heuristically in some ways, so that we know the amount of kilometers that we have to cover to go with fiber from the gateway to the point of presence, and from there, what we assume whether we can reach an IXP. And then, so with this, we can design our backhaul, and we can actually enforce a specific capacity per user, per subscriber. So how do we model the cost? It's extremely complicated. You're gonna find all the sources of the data in the paper, because what we are trying to, what we do is actually we have the cost for all the physical devices. So wireless routers, wired router, fiber itself. We have the deployment costs of the wireless backhaul. So how much it costs to mount a specific node, how much it costs to mount the gateway. And we have the cost of the deployment of fiber to the point of presence. This is aerial fiber, that the model that we use. And then we have, this is CAPEX, and then we have OPEX. We have the wholesale capacity that we buy at the IXP. We have the transport to reach the IXP from the point of presence. We have maintenance that is based on the mean time to fail and mean time to repair of the devices, specifically the wireless devices that are hundreds. And we have energy cost, which we derive from the maximum energy consumption of the devices, which we scale down. All the data come from public sources, previous papers, or interactions with the GIFINet people, because at the time, Jorans was at UPC, Gabriele was at UPC, so we have them at hand, and so we could ask them, look, when something breaks, how much money do you spend to send somebody there and fix the antenna? So based on this, we could actually do an estimation of the cost of the infrastructure. And well, this is just a big formula to say how we estimate the cost per month per subscriber. And the important thing here is, okay, we have an OPEX, which we divide by the number of subscribers and by 12 months. The rest of the thing, it's amortized in 15 or 5 years. So we assume that the fiber is going to be amortized in 15 years. So the cost for deploying the fiber, we divide it by 180. And the cost for all the wireless infrastructure, it amortized in 5 years. And this, because we found in the literature similar estimation for wireless infrastructure, we assume that the fiber is there and it's going to be there. You can even resell it and use it for other things. So we amortize it in a longer period, while the wireless things, probably in 5 years, you're going to have to change them anyway. So this said, some results, again, very dense. What we have here is the monthly cost. This is the penetration, so 25% of the population, 50% and 100%. And this is the capacity that we give per subscriber. Now, focus just on the squares here. If I have a minute, I will also comment on the X. What you have here, this is the cost of the network when you're using 11 AD. So 70 gigahertz, and that's the same when you're using 11 AC. And with 11 AC, we do some like basic connectivity. Okay, with AC and 5 gigahertz, we focus on cheap things, and with AD, we try to reach higher capacity. And this linearity here is mostly due to the cost of the wholesale capacity and transport. And this difference here is the cost of the devices. Again, updated to 1.5 years ago. And the cost with penetration 25%, it's kind of reasonable, between 30 and 60 euros That's the monthly cost. And of course, if you increase the penetration, the cost decreases because the denser network repays itself more if you have more subscribers. Okay, so if you want to reach somebody that is far away, you're gonna need a new branch of the network going there, and this is it costs too much if you have to reach only one person. Then this is a comparison with what was available at the time. So the first, okay, these are two profiles. This is with AC and this is with AD, and the difference it's in here. This is the minimum capacity that we estimate for every subscriber. So in this case, and this is the penetration that we estimate in, well, we use as a parameter in the specific column. So these are low capacity, so minimum, the target here was 5 megabit per second. We can achieve a little more because we over provision, and the target here was about, I think, 60, and we can achieve more because, again, we over provision. So that's the minimum that our model says we give to every subscriber. At the same time, we only had DSL, XDSL in those areas that guarantee you 7.5, guarantee you 7.5. That's what they claim, and also Starlink that we didn't know what's guaranteeing at the time. And this is the upfront cost. So that's if you build the whole infrastructure and split the cost, so the capex between all the subscribers, this is what they're going to pay just to build the infrastructure. And this is the upfront cost that you spend with DSL and SAT. This is normally, you don't pay it upfront in Italy, at least you pay it in like 2 years or 3 years with your bills. And that's what at the time you used to spend with satellite. And that's instead the monthly cost, assuming that that upfront cost it's amortized in the period that I've mentioned before. So in the end, this is the amount of money that you're going to spend with connectivity, with a low profile connectivity or with a high profile connectivity. And this is kind of comparable with what we have, with what we used to have at the time with the DSL or with satellite connection. The only thing is here we don't count is that there is no loan here. Okay, so you should probably add 3 or 5% this, because if you don't put the money up front, then you have the money from bank, and we didn't count it here. And then we have those connected households here, unconnected. This means these are the original data from the state. XDSL doesn't reach 18% of the households, and these are the numbers that we don't reach with our own design. But this is it's an upper bound because we don't optimize for that. In some cases, you need like an upper pole or a trellis somewhere, or a place or node place in a specific place that can cover a certain area, and we simply don't do it. We don't do any kind of this optimization. So that's all on my side. We have a well-documented model from planning and evaluating the cost of our mesh-based backhaul. It can be parameterized as needed. Of course, the code is there, and the price ranges we computed are more or less comparable to what was available at the time in Italy as an alternative. And now I'm ready to take questions if you have them.
All right, cool. Thank you. So the queue has started to fill up. Please use the queue if you have any questions. I'm up first because I jumped in pretty early. So just as a quick question on one of the earlier slides, the selection of the gateway seemed to happen before the cost of the fiber roll to the gateway. It makes more sense to me intuitively to say that you picked the gateway based on minimizing the fiber roll, because that's probably the most expensive step. Is there a reason you did it that way, or did I misunderstand?
The point is that then you're going to have fatter links to reach. If the gateway is not in the center of the cluster, then you're going to spend more money for having more capacity on the links, because you're going to have longer paths. But that's possible. I mean, we didn't try the alternative.
I suppose that's just another kind of optimization question that hasn't been done. Okay, makes sense.
Alistair Woodman. So you're costing the levels you came out with would seem to indicate that the telcos are relatively rational economic actors, in the sense that they don't want to serve rural areas because it's actually very expensive. Is that your conclusion?
I don't know if that's my conclusion, because in the end they got a lot of public money to serve those areas. So
Right. So if you ignore the public money, then they're rationally not doing that, right? So the question is, are they pocketing that money?
It could be, but I don't have an answer for this. I mean,
Because did you compare the price that they're charging people in the cities? So I presume that they're also only charging them sort of 660 euros in the cities for service, right?
I think that's the same price you get everywhere in Italy.
That's the point, right? So it's cost effective for them to do it in the cities because of density, and it's not cost effective for them to do it in the regional areas because of lack of density.
And
right?
still, I mean, they miss a lot of people here.
Well, right, because they don't really want to do it, right? So you're saying that the subsidies, so you could use what you've calculated to invert for the regulators what the actual subsidy should be in certain areas if they actually wanted to get better density coverage.
Yeah.
Okay.
Any other questions? I have one.
Yeah, I know it's Leandro. It's a tough question, but do you have an estimate of how the numbers would look like as of today? I mean, how is the evolution of the market, and to what extent your conclusions apply or are different, would be different as of today or maybe next year?
Well, I think this didn't change. I think we didn't have investment in public infrastructure in the last couple of years. So what was reached, and what was not reached, it's done. Probably the cost of the devices, it's much lower, and probably the gap there, it's reduced. So we could save some more money. And actually, we were pretty pessimistic in many of our accounting, so we try to keep the price high, so to have an upper bound. And if I have one last minute, one of the reviewers said, like, what happens if you don't have the fiber backhaul? Like, assume that you have a satellite link for every cluster. So this is the price of the infrastructure without the fiber and without the wholesale capacity. And at the time when we were looking for satellite links for the backhaul, we only had the price for Starlink, which has an option. It's like a community gateway or something like that, and the cost was enormous. Like the upfront cost was more than the cost of the whole capex that we had. So that's what you have if you have a magic uplink, which you don't have, but that's it.
We do have a little bit of a moment. So I wanted to add on so I'm in a bunch of the WISP groups on Facebook. If you're interested in this stuff, the WISP groups on Facebook are delightfully churny, punchy people arguing about this. And they are just getting crushed by Starlink. And they complain, they sit around saying, hey, like we're better on price, basically. But people are still going to Starlink for reasons that they argue are irrational, but potentially are still irrational. Maybe it's sometimes about downtime. Sometimes it's just like the big corporation is safer conceptually. How do you feel about the structure of these wireless ISPs given this rollout?
I mean, that we have. We have quite some experience with community managed networks in Italy, and as we were commenting before, they had hard times when we started to have investment in broadband around. So many of those infrastructure didn't resist because the provider was getting there, even if it was having bad. So they have the same problem. They have the same competition with Starlink. But by the way, Starlink, I don't think this price changed here. But that's higher than the one the market offers in Italy. So, but the fact that the network is community based, it's certainly hard to keep going.
Yeah. I guess we have one more.
Thank you, Leonardo, for the presentation. My name is Bill Baraza from Kenya. I head an organization that's also doing a few projects around community-centered connectivity initiatives. My question is around I came in when you already started the presentation, but I just want to know, in terms of the infrastructure and the equipment, some of the suppliers we've been able to use for the radio side and the core network, because you're right now trying to pilot a community network in Nairobi, in a far-flung area from where we have very underserved communities. So I'd like to know what devices and manufacturers we have deployed in Italy to be able to get this costing on campus.
Okay, this was completely simulation, but we were using the data from Ubiquiti gears and Microtic gears, and we were extracting the Ubiquiti has a planner that you can use to plan the links, and we were extracting the data from the planner so that we could dimension the links, and so we think it's pretty accurate for those two family of devices, and Microtic similarly.
All right. Thank you all. I might have messed it up. It was you. Have you guys? I think it's you and then me, and then Leandro, then Steve. Might be Steve, then Leandro.
Hi, I am Marcelo Santos from Brazil. I'm a professor at Federal Institute of Sertão Pernambucano. I will present today the CNRMN. I know it's a terrible name, we can improve it. It's a community network readiness and maturity model. So let me know who knows what is a community network. I believe most of the people here, but please raise your hand if you know what's a community network here. Okay, most of the people. So I will be brief about community networks here, but we needed to have in mind the purpose of a community network. Of course, the first thing that come up in the mind is connect unconnected people. But sometimes, because it's expensive and for the community, and we needed to have another option cheaper. Well, so from my experience in Brazil, in rural zones and other kind of communities, we don't need heroes. Generally, we think if we go to the community, connect a lot of devices with fiber, Starlink, doesn't matter, it will solve the problem. It will not. Because after 6 months, 1 year, the community network will stop because we don't have a governance. So it's more important if we think about a continuous network working for a long time. It's more important to have a methodology to give a governance very structured. So it's not about put a lot of devices with gas LEDs blinking, but we need to have sustainability, and we have a gap. We have a lot of NGOs and universities, and I'm from university, creating community networks, but after a few months, the network stop. I mean, we have a lot of gaps here, like if, for instance, one volunteer leave the community, and he has the whole knowledge about passwords and how the network works, and it's one of the problems. Or one equipment stop, and they don't have enough money to replace this equipment. So community networks do not need only deployment. They need continued autonomy and learning. We need to transfer the knowledge to the community. It's the big challenge. So what we propose here is a readiness and maturity framework. We have a lot of manual toolkits from ISOC, APC, a lot of entities with fantastic materials, talk about community networks, how to implement, how to choose the better device, MikroTik, doesn't matter, Starlink. But we don't have a material talk about the life of cycle guidance to have this network working for a long time. So we propose a framework architecture based on 3 pillars: the life cycle stage, 5 stages, and we start with community readiness, planning, deployment, operations, and evolutions. I think it's the main contribution of this work. Based in some dimensions: social, governance, technical, financial, local capacity, partnership, and regulation. And with some maturity steps, like initial, defined, established, systemized. This slide shows the main contribution. So we define what we need to do, not exactly how. For instance, in the first step, we need to have a mobilization of the community. We need to talk with the leadership. And it's fantastic if you think about it. It's not enough go to the community and put the equipment, device, connect, fiber, and so on, if they don't have the intention to maintain this network. Because the community networks, I'm not the owner. We don't have a provider. I will give a short example about that. I went last year to a community to a rural zone community, and I spent 40 minutes talking about community networks with the people there, and they answered me, "Professor, we don't have union here. We don't have. We want have this mobilization here to build a community network. We want only a cable of internet, but we don't have. We wouldn't like to have more effort because we don't have time. We need to put water in my culture here, and we needed to listen the community. But in my purpose here, we have these K processes. We have stages, stage 1, 2, 3, 4, 5, and we have this K process. So in the first stage, we needed to mobilize the community, create a diagnosis. After that, we can, in this stage 0, realize that community networks doesn't have fit with this community, and it's a good result. In the stage 1, we plan the design of the network, and the stage 2, we think about the deployment, inventory of the devices, the documentation, installation. If someone leave the community, just read the material created. We need to have financial management in the stage 3, monitoring, maintenance, and documentation to guide the community. And what is interesting here, it's because we say what they needed to do, not how. And I give an example better about that. We say, okay, in some stage, you need to have a financial plan. And we have a toolkit from iLook, fantastic. And when we open the toolkit, we have Excel with a lot of fields to fulfill. I can't say for agriculture, use this Excel. It's very hard for him. So we say here, you need to have a financial plan, but how the community decide. It could have a notebook with a pen available in some place for everybody to look. They needed to have this plan, but we don't define how we will implement that. So we say what they need to do, not how exactly. And we argue they needed to have also evidence. We have a framework, we have steps, we have stages, we have key processes, and they needed to have evidence. For instance, okay, they will plan the financial during the time, and what's the evidence? Okay, the notebook with a photo. We needed to mobilize the community, the leadership, and the community, and so on in the beginning of the network in the stage 0. And what's the evidence that they did that? A photo, paper with the signatures from everybody, and here we have examples of evidence like meeting minutes, photos, financial records, because we can use some entity to certify this community. Maybe IASOC, maybe another entity. If this community implement this framework, we can have a certification for this community. So what CNRMM is not, it's not exactly only a audit tribunal. It's not the final purpose here. It's not a bureaucracy. It is a little bit, but the community can decide how implement that. Not all the stages, not everything that we propose here. It's not a race for a maturity score. It's not first all deployment receipt. This work, it's a facilitation for implement community networks. And look this figure here. In the beginning, we have a person with knowledge, of course, high knowledge, to transfer knowledge to the community. But after stages 0, 1, 2, 3, this involvement of this person or entity is minimal. We have here the community autonomy in the end of the process, a self-sustainability for the community. So this proposal is not about only bureaucracy. It's about helping community networks stay alive, autonomous, and meaningful over the time. So thank you.
All right, everybody, the queue is open. I'm gonna stop using my moderator privilege for a moment. So, okay.
Hi, Leandro Navarro. Thank you very much for the effort to structure the how communities, well, which are the ingredients that community networks use, have, whatever. And you mentioned about the what and the how or something like that. I think there's a tricky point in which we have to find out to what extent we are able to provide something useful for everyone, let's say, communities or observers or
Yes.
whatever, in a way that it describes but it doesn't prescribe things. Because if you compare, for instance, with software development, there's a typical discussion about the waterfall model or the agile methods, among other methods.
Yes.
So it's a tricky point to be useful but not to be prescriptive. I've seen different community networks evolve in very different ways. You can even see the opposite. Let's say, typically in rural areas, sometimes when you go and discuss with them about creating a community network, they say, okay, that's what we do with water, with forests. So we know how to do. We have a governance. We have everything. Oh, tell us how to apply our practices for networks. And they have a different start from a champion that starts by himself and tries to create a community around. I like very much one researcher, Elinor Ostrom, a Nobel Prize of Economy, who said that what works in practice should work in theory. So it's I think there's a challenge in trying to see how communities resolve their problems and organize themselves in a kind of strange manner, but works. And then try to observe and extract some patterns which can help us to collect them and offer them processed to the community. So that, I mean, there's a lot of potential here, a lot of knowledge that can be kind of gathered and offered properly to the community as a document from the group. Thank you.
Thank you. I think what we can discuss and improve is these steps and the stages. I think it's the main contribution, like you described before. It's a clear step that the whole community network should follow, but with what key processes. So here we have 27 practices, and we can discuss what they should to do in each stage. I think it's a good discussion and improvement of the work.
Hi, Leonardo from Ca' Foscari of the University of Venice. Just to add that to what Leandro said, in the project that we had at the time, netcommons.eu, there is a significant amount of work done also on this subject. So there is a lot of overlapping. There are descriptions of the trajectory of many community networks that have been going through all those steps, and there is also a manual, like a how to deal with most of the things that you mentioned, because they happen all the times. And we even had like a card game that you could use to discuss with other people in the community, so to raise those points without making it look like, you know, a lot of bureaucracy and stuff that you have to do on top of the time that you still don't have to go on the roof and mount the wireless device. So check it out.
Okay, fantastic. Like you described before, it's important to, for instance, estimate the cost, of course. And we say it's necessary, but we don't say how you can use, for instance, your methodology. But we won't put specifically how to calculate the cost, for instance. We need to say it's necessary, how the community decide with the entity or deployment the community network. So here it's a framework. It's a step by step. And okay, thank you for that.
But based on our experience, I mean, it's a double-edged sword. Sometimes you have people that just want to know how and what they have to do now.
Yes.
Sometimes you have other people that don't have that mindset. Okay, you cannot just prescribe them that you have to do this, but you have to explain them why it is important to do so. So it's very local specific.
Yes, I completely agree with you. But from my experience also, if you don't have this transfer of knowledge, the community network tends to die.
Yeah, I agree.
Hi, Juan Peirano, Internet Society. Thank you very much, Marcelo, for the presentation. It's a bit of a two-part question. You had a list there when you mentioned that you sort of like give a stamp based on the information that you gather from the community network to follow up how they are evolving through the stages. My question is, does the Instituto Pernambuco give a certificate in any way, shape, or form? And if you do, or if you don't, but what do you think about having such stamp of approval from a university or someone saying this CN or this community network has evolved to a certain stage, and how that might help getting them more financing, particularly for stage 4? Do you think that's something that is useful or not?
Yes, I think it's very useful. It's an initial work. So it's only the first presentation about this work, to be honest. So it's let me try to explain a little bit better. It's totally useful to have a certification, an entity that gives a certification and so on. We don't have something like that yet, and we don't have a budget to do that and to give the certification, but it's extremely necessary to have a main entity responsible for that. And I go beyond that. It's important to have an entity, for instance, like ISOC, and it's important to have other entities trained with this framework, like an NGO, like we can have in the top ISOC, we can have an NGO trained by iLook based on this framework, and they can have, after that, they can implement, help or give some support to implement community networks in every place. So in summary, it's important to have these certifications for the community, but it's important to have a certification only also for some entities. And generally, it's work better when you have something in the top organizing everything.
And just a brief reminder maybe is to, if you can join the Meet Echo queue, it helps the note taker. So they can get your name more easily than chasing you down. Okay, so I think we'll start. I'm in the queue next, but basically I've been chewing on what Leandro said a little bit in my head, and I'm talking next anyway. So I'll just do that. So thank you very much.
Thank you.
Take back slides.
Maybe also just a reminder to sign in general.
Yeah.
In this case, it wasn't. I couldn't find when they're not signed in. So
Yeah.
Please sign it.
Hi, everyone. Yeah, and that was a really good question, Leandro. I'm just thinking through like how technologies map to social structures, and how some are better at certain social structures than other ones. I think a big thing we did in Indonesia was not try to change the existing structure of whatever, and we just went with what our partner had structured, which was like a normal for-profit entity, which we got some pushback on. But I mean, that network lived for over 10 years. Interesting. Okay, so hi everyone. I'm Curtis Heimerl. I'm one of the co-chairs of GAIA, but come here with a talk this time. This is actually a presentation from HotNet's 2025. It was a paper that we published there, focused on broadly human methods in networking, of which I'm one of a small set of researchers that really live in that space. So this is a talk for the researchers in the room, and specifically the networking researchers, with the hope of sort of expanding your mind a little bit to other methods and potentially providing a nice, robust space for debating those methods. Because often when I present this kind of stuff to deeply technical researchers, I get a lot of pushback on maybe the scientific validity of them, the value of them, and these kind of things. But I'm one of a handful of people who regularly publish at human-computer interaction venues as well as networking venues. And these are kind of hard-won battles over a long time that hopefully what comes out of this is a, I didn't start my timer, sorry. No, I did start my timer. Hopefully the thing that comes out of this is a little bit more in your quiver as researchers to bring. And the one I'm really going to harp on is participatory action and action research in general as a method. So the big piece of this is to say that an enormous amount of human-centered work happens in networking research. And we're not even talking like we're in GAIA, and you can see there's a strong community networks theme going on in the room. And so as researchers, as networking researchers, this is a group that I think does more sort of direct human work than most. But even like your data center researcher working at, at Google actually has, hundreds of hours of meetings with various stakeholders trying to understand the problem and the ecosystem. And then they write up this paper where it's like, this number is better than this number, and so the system is good. And all of that human side of things just kind of gets removed, with the intuition being that that human piece of stuff is like not scientific, it's not valid, it's not interesting. And so the scope of this paper, and again, if you just go, you can go to my website or HotNet's and see this paper there, is trying to expand networking to take into those pieces, not just because that research happened, but also because that's critical to understanding the research contribution that happened and understanding the value of it. And so all of that work that happens, and I think the IETF is one of those places where a lot of it actually does happen, is important to bring into your research, not just, again, to broaden where you can publish, but also for correctness. Like understanding why something happens and why decisions are made is just as critical as which number is higher than than which other number. And so the argument here is, of course, that these insights should no longer be treated as this kind of background noise, this unscientific thing that happens, but instead as central pieces of what networking research is. Now, there is a long history of human methods in huge conferences. CHI as a venue is the big one in HCI, and that is larger than SIGCOMM and NSDI put together. It's an enormous, very silly conference, for the record, if you've never been. It's one of those ones with like 20 parallel tracks, and if you get bored, you can just wander and find the like weirdest session, my favorite of which was foot-based interfaces. There's a session of just 5 papers on that. They also have a really interesting subset of people who do animal-computer interaction, which is like apps for your dogs. So you can always find something interesting at CHI. I highly suggest you go. This is no value judgment, positive or negative, on the work, but it's fun to sit in on, and something as a layperson I can do relatively easily. But through these human methods, we kind of picked out 3 that we thought the networking community in particular should make more use of. These are participatory and action research, ethnographic methods, and positionality. There are many, many other ones. Surveys are interestingly one that actually do get used in networks, but get used very poorly. We left that out of this particular paper because that's like a whole other side paper of me yelling about statistics and survey methodology. But woe to the person who gets me assigned as their reviewer at SIGCOMM when they have a survey in their paper, because it's often not very methodologically strong. But anyway, I'll step into these 3, and we're really going to focus on action research. I think it's actually just what we all do and don't have a word for. So action research. Participatory action research, known as PAR, strives to have active partner participation at all levels of the research. The basic idea here is to work with partners first, like pick out partners, and then work from project ideation to evaluation to empower the partners to actually solve their own problems. The idea is you go in without a problem in mind necessarily. You have a toolbox. You're a networking researcher. So you're not going to go in and like not work on networks. You're going to say, hey, I'm a networking researcher. We'll find something. But you don't come in with like, I'm going to optimize this particular thing. Please help me with that. Instead, you go in and say like, what sucks? Right? And then the person's like, well, this sucks. And you're like, okay, we'll work on that together. And that's really the heart of participatory action research as a methodology. Now, what's interesting is it does go all the way through to evaluation. You have to evaluate a way that like your partner cares about and your partner understands the output of it. And this can be a little painful because often the partner, what they care about is maybe not what necessarily the research community cares about. So we work with partners through and through. You iteratively develop and evaluate these interventions that you decide on based on the goals that the partner has. When we say social change here, that's a fun side discussion on the sort of history of these methods. They come from activist communities. And so fundamentally, by design, action research is supposed to work on social change. Now, that is obviously a very broad definition. And so as long as you're working with a partner that's focused on some kind of impact thing, you're doing that. And then you actually ideally even include partners in the authoring of the work. This can sometimes get a little bit wonky as well because they don't really care or know what SIGCOMM is. But that's really the ideal when you look at someone's paper to see the actual partners on it. Our big critical argument we make in the paper is really that like this is what we all did. This is the internet. This is even the IETF, right? The whole point of this is to get the interested stakeholders in a room together to understand what their problems are, work with them on those problems, and output stuff. Now, the interesting thing with the internet, of course, people probably have a working understanding of the history of the internet in the room. Probably some people have a better understanding than I have of the history of the internet in the room, right? But circa 1960s, DARPA's like, hey, we need to build a new network that can survive a nuclear missile attack. And so they engage with some researchers, and those researchers back and forth. Now, you might say, is DARPA a social change organization? I would say yes, for better or for worse. But right, they weren't making these choices just for financial consideration. The point wasn't let's make the most efficient network that we can charge for. The people in France building the GSM network were doing that. And those networks came up at the same time. And so basically everything that happens here where you, again, go to a partner, work with that partner, they identify the problem, you work on them with the problem, you output stuff, is action research. And I think it's really fundamental to actually the history and practice of computer networking and computer networking research. And what's interesting to me is it's just something that we don't talk about. All you do is come out at the end of the day and say, well, we've made this particular algorithm or this particular system faster or slower, but not really what's the problem that the organization we're working with is trying to solve. Now, if you go to a big academic conference, the answer is almost universally at this moment, we are trying to get more money out of our infrastructure. But that's still, I think, a fine answer to understand and to forefront. And so we had this paper at SIGCOMM 2024 on our architecture for the Seattle Community Network, which is a cellular network that we run there in a community style fashion. And in that paper, I think we specifically call out that we were doing action research with our partners. This manifested for us in that we built a distributed core network architecture. The critique of it we got from the reviewers is, why don't you do this in the cloud? Why are you building this distributed architecture that's more fault resilient? If you just put everything in the cloud, there won't be a need for that. And the answer is, our partners don't want to put things in the cloud. They don't trust the cloud. And like that political angle and that sort of goal of social change from our partners really drove the design of the work in a way that it was really nice to be able to forefront in that particular paper. So on from here, but again, I think PAR is the most interesting one. There's also just a broad set of ethnographic methods. And where's my clock? Okay, I'm good. Ethnographic methods have a really fun history as well. So ethnography, if people know, is this like branch of anthropology where the big idea is to go and actually embed yourself in a community for a long time and then really write about your experiences and perspectives on that. Sometimes traditional ethnography work is you go and you hang out, and the big thing is to like do the work with people. So if you're doing an ethnography of a particular workplace, you should work there. It's not just observational. That's sort of traditional anthropology, is someone sitting and like writing about what they see. Ethnography, you should go and you like do the thing with everyone, right? And this goes on to a space called autoethnography, where you write about yourself doing that work, versus ethnography, you just participate and then write on the people around you. And the big goal of this is, I think the interesting distinction from what people consider traditional science and this is that you're no longer going for generalizability in any meaningful sense. The goal of ethnography is not to develop knowledge that replicates across multiple areas, but instead really generate knowledge that's very specific to an environment. With the idea is that there's so many different environments that specific knowledge will be really interesting. And sometimes that can be a tension when you're publishing work, because the question will be like, how do I make use of this? The answer being you don't, but is it interesting? And hopefully the answer is yes. So to do this, what you really do is situate yourself inside of these relevant communities. This is the Tribal Broadband Bootcamp, where my student Esther has been teaching for, God, it's probably 5 years now, teaching wireless at these particular environments. So she goes, she's never written a paper on it. She just kind of does it because she really enjoys it. I guess they pay her. That's actually fair. Yeah, it is, I think, that broad piece of ethnography research where she's there to participate, engage, and be a part of the process, and not just be there observing the process. And then you have to document everything, which is my pain point. I actually am quite bad at this as a method, because I'm not that kind of person who takes notes. But taking notes every day of everything that goes on, your thoughts, your experiences, so that you can go back to them. And you use a set of tools, a set of methodologies to be able to glean information and distill information from your big set of notes to come out of that. And that's coding, which is this widely overloaded term in the world. But you do this sort of ethnographic coding to get data out the other side. And that's that formal understanding there. We had this great example in the paper. Again, if you want the deeper version, go take a look. One of our authors doing this in IXPs. So she went and she participated in IXPs down in the Global South, I believe, in Central America, if I remember right, watching how BGP peering happened in that particular environment. You know, you go to a SIGCOMM, maybe even here, and you talk about BGP and these technical arguments for what gets supported. And then you go to where, like a NANOG or these other sort of industry environments where BGP peering actually happens, you know, and it's like, let's go get a drink together and talk about the peering. It's not like a protocol discussion. It's often a really informal, personal business relationship discussion with various stakeholders, and being able to document that. And the role of the protocol in that process was a key thing that she was able to publish. That was really cool. Lastly, and I think most interesting, or not most interesting, most controversially, is this concept of positionality. And positionality is something that comes from, again, these other spaces. And the big idea here is, as a researcher, for you to kind of say what perspective you're bringing to a piece of research. So what you'll do is you'll question your methods, your results, everything where your personal perspective influences that. Now, traditionally, what this is an understanding that, like, if I, as a white guy from a large public university in the U.S., goes to Indonesia to do my work, I'm going to be viewed in certain ways. In Indonesia, for example, I was viewed as a missionary. I am not a particularly religious person, but that's what the white people there were, and so I was just immediately put in that bucket, right? And that's relevant to the research, like where I go, what networks I get to deploy, what interactions I have, they're all affected by that reality. Now, you might ask, if you're publishing something about data centers, maybe that sort of positionality is not that relevant. And I think everyone can kind of reflect on how their positionality does affect the research. But I think if you're a researcher at Google, or if you're a researcher at a university, that does affect that research. You know, you're going to have different doors open. You're going to have different perspectives on you. So it doesn't need to be this kind of identity style of positionality. There's a whole other genre of this. My favorite version right now is if you look at the operational systems tracks at these conferences. These are places where industry folks can come in and present kind of industry perspectives on research, like stuff that they reflect on their own kind of work in industry. And the immediate question is, like, what's the positionality of one of those researchers? And we went back and we looked at a bunch of the papers, and invariably the reason people work on that work is because they're paid. They're just like, that's their job, right? That's the positionality. 100% of operational systems tracks papers at these conferences are that. And it's just subtext at this moment, right? You just look, this is a researcher from Google working on this Google system. They're doing it for that reason, right? And so we're right now trying to draft up an operational systems track paper for our Seattle community network to sort of have a different positionality come to that track that I don't think has been present in the networking research, at least in the papers I've looked at recently. And so this is sort of that, just reflecting on your role in the research. What of your identity, what of your perspective, what of the way you present yourself is relevant to this research? Put it in the paper so that people can recognize that piece of the contribution. And then we had a little bit of a thing on how the different communities, research communities, engage with that. Here's our example from the Seattle Community Network, which is, again, that, like, we are university researchers, obviously activists, obviously somewhat radical. And that really, I think, pushed that SIGCOMM paper that we had. We were able to put that in there and say, hey, like, look, we're building it because we're radicals, not because we're trying to build a more efficient core network. That's explicitly not our goal. So the general recommendations, if you're going to start to kind of go in this way with your research work, is to document partnerships, detail everything, just write stuff down. It's kind of weird to document your one-on-one conversations with people, but it's really important to be able to reflect on, this is data in this system, and then actually reflect on it from there. And so here was our call out for the network research community, which was to, like, actually allow this in the CFPs. We haven't gotten there yet, but I'm gonna, keep fighting my battles. So that's it. This was a big collaboration from a whole number of researchers. We actually had an NSF grant to do human-centered networking in a workshop, which we held about 1.5 years ago. And this is all kind of our dissemination steps for that particular thing. We'll see what happens from now. The NSF is a little bit chaotic, as you may or may not have heard, but they, at least the program manager seems to still like us. So I will end there and with a small amount for questions. We have a Christopher in the queue.
Hi, Curtis. Great presentation. I'm Chris Locke from Internet Society Foundation. Linking this back to the previous presentation, I think one of the absolutely fundamental values of research approaches like this is actually in helping inform long-term sustainability of the community network programs. If you understand the human level of usage and the economic and social aspects that people bring to the usage of their system, it fundamentally helps you building community networks that absolutely are eventually long-term sustainable. in a previous role, funded research that examined Facebook Zero's program in India, where we discovered that actually it hadn't brought anyone new to the internet, but was being used by an already partially wealthy middle class to reduce their overall mobile spend on a monthly basis. So doing that, I think, really links through. And one of the things on top of the recommendations you make, I would strongly ask everyone working on any form of community networking, is having that deep understanding of the usage patterns and the activities that people bring to the way they use the networks in social structures and familial structures as a way of informing what sustainability looks like.
Yeah, thank you for that. I think that's absolutely correct. And, you know, one big piece I want to reinforce is that I think a lot of this is about correctness. Like without this information, like you're missing fundamental elements of the research. So if you write that community networks paper without these elements, it's harder for people to replicate. It's harder for people to understand. And so having that data is really important for telling the whole story so that other people can take it and run with it, which is the goal of science. Or a goal, I should say. You have a Sophie?
Thank you very much for the presentation. Really fascinating. I did research at also IXPs, but at DKICS, so at a larger one. And I'm really interested and curious, what do you think, should there be more research on not just community networks, but also to genuinely, also when it comes to positionality, reverse the gaze in a way and also look at very corporate for-profit models?
Yeah, I mean, this was a presentation for like the entire networking community, so I completely agree. I think there's, you know, even like IXPs are such a fascinating environment. I've only like bounced off them. My favorite version, I was in Indonesia, and one of my friends connected me to the big IXP in Jakarta, which handled 80% of Indonesia's traffic, which is an enormous country, right? And it's just a mom and pop, and they live upstairs. Like, it was just mind-boggling to me, that whole ecosystem. I understand it's corporatizing in ways that maybe makes things a little bit less exciting, simpler, you know, better by someone's definition and worse by another. But I highly suggest you look at Fernanda Rosa. She's a professor at Virginia Tech who did that IXP work as an example of someone chasing that down. It sounds like your work is super interesting as well in that space. So I completely agree. Like, this isn't just about how to do community networks better. I think the community networks community of researchers has taken a lot of these methods to heart over a long time. But I think even into those corporate levels, and even like the same things are happening and the same questions are there, and the research is missing this piece that's really critical to understanding what's going on at even highly corporate IXPs. They're still going to the nanogs and making weird deals. So thank you for that. You have a Renzo?
Yes, Renzo Navas, IMT Atlantic. Thank you, great presentation. I have a question. I'm a researcher. I want to engage on these kinds of things, doing things I value and that helps the community. My question is, how you find the financing to do this? Where do you go look to your partners? Personally, I will start in my local community and go see people and public actors maybe. But of course, maybe it's not enough. What's your experience on getting funding and getting people on board or entities?
Yeah, this is why we're starting at this like researcher level, as I think we need to reshift what the research community appreciates, because a lot of the funders, at least for science foundations and the like, kind of follow that. But at the end of the day, I think this particular argument is to say you should do this as part of good networking research. So whatever funding exists for your existing networking, you should just bring these perspectives and methods and be able to acknowledge if you're doing action research, who you're doing action research for, how you picked your problems, what your perspectives that you bring change things. That's good networking research. And hopefully if we can move the community a little bit, the funders will follow. That's not to say that like the general community networking space also has our funding challenges for this kind of stuff, and solving that is, I would say, potentially out of scope for this talk, but like close to my heart, if it's not clear.
Thank you.
I think I should stop with Rumezia.
Hi, Ramesa, PhD student at Stanford. I really enjoyed your talk. Like, I think this is something that the research community really needs to talk more about. During my undergrad, which I did in Pakistan, I remember there was a visiting PhD student from Paris who was like, who wanted to learn more about infrastructure in developing regions. And I just remember thinking, why don't people do this more often? So I guess that's my question to you, because like people at these home institutions, especially in developing regions, are actually really excited to share how their world of it, the internet works. But we don't really see that often. What do you think is the barrier over there?
The research community is kind of myopically self-centered in this like really problematic way. I'm sure you've experienced it's a big discussion at GAIA all the time of like, if you do some research, like you're doing some study on people, you can write the study, but if you do the study on people in Pakistan, you have to put "in Pakistan" in the title of the paper.
Right.
Like the same research, if it's not in Pakistan, you can just say like it's happening. If it's in Europe, it's just happening. But if it's in Pakistan, it's happening in Pakistan. Otherwise, the reviewers will be like, why is this relevant to me?
Right.
Like, how does this generalize out of Pakistan? But no one's asking, how does this generalize out of Germany?
Yeah.
And it's just this like centering of methods and understanding both, I think, for HCI in the global north, but in networking, largely in companies. And so when I write a paper, I have to sort of justify that why we're doing something different than just like putting things in the cloud.
Yeah.
And I think this is part of that effort. I think that Kai's done a really good job at this point. Like you don't have to do that anymore. You still get some pushback. I'm an AC there, and I have to tell the reviewers like, no, it's fine. But networking, I think we just all have, and I think networking is actually like really thirsty for non-data center work.
Yeah. Yeah.
Like, everyone is so tired of data centers, but like that's where all the money is. Like that's what Google funds, all this kind of stuff. So I'm hoping it's an opportunity right now to be able to open that door a little bit. And it sounds like you can be part of that process as well.
Yeah. I'd love to chat more about that.
Okay.
Thank you.
All right. Thanks, everyone. I guess we have Steve next. My thought is the RFC is probably the most open-ended, so we'll just run that to the end. You don't have slides, right? So are you going to talk, or do you want to present? You're still going to have like a thing.
I'm going to share my screen.
Okay, so then I'm going to
screen share request.
Yes. I didn't get it because I was standing up. But I will find you.
So while I'm being found,
there you are.
What I want to convince you of today, or to tempt you with today, is to become a mapper of fiber optic network infrastructure. So the reason I and a number of us are here this week is for a governance meeting of the Open Fiber Data Standard. And if you haven't heard of that, it's very simple. It's a structured language for describing terrestrial fiber optic networks. There's lots of information available about undersea cables. You can find maps of undersea cables at Telegeography and elsewhere.
You should have screen now, although I think my slides are still up, so you have to kill those. But you should have screen control.
Okay. So if I... I'm not seeing anything.
Okay, let's just...
You know what? I'm just going to talk. I think... and if the screen appears, that's great.
I will play with it.
So, and linking this back, terrestrial infrastructure back to the discussion of community networks, we often talk about the last mile of community networks and the sustainability of the infrastructure. But one of the key issues of sustainability in community network infrastructure is actually backhaul. As demand for broadband increases, backhaul becomes one of the most significant factors in the sustainability of any network. And the key to solving that affordability is actually getting to the deep water ports of the internet, which is fiber optic infrastructure. We can have a side conversation about Starlink and its impact and retail versus wholesale networks, but fiber is the kind of gold standard for the internet. And yet, when it comes to terrestrial networks, it's really hard to find out where it is. I live in Nova Scotia on the east coast of Canada in a very rural area. In my community, we formed a cooperative. We got a non-dominant operator license from the Canadian regulator. And we approached the incumbents, Bell Canada and Rogers, and we asked them, well, can you show us where your points of presence are so that we can connect our network to you? And they declined. They refused to share their network maps. They played a kind of a game of Go Fish. I don't know if you played that before, but as a child, do you have any fives? You could give them a location and they would tell you if they had something in proximity to it, but you couldn't get access to their network infrastructure. And this becomes an issue not just for, okay.
Whatever the appropriate tab is.
Can I sit down?
Yes, yes.
All right. Oh, it's.
I shared the wrong one. Okay. We've got time.
Can I share the whole screen?
Stop sharing. And then, so you've got screen share down here, and it's going to ask you which one. So, did you close it? I'll grant you screen share again. So now you have to pick the right window. So that's going to share this window, which is not the window you want to share.
Can I share
So
the
if you
desktop?
Tab to your, no, I guess it's just window.
Okay, all right.
Oh, no, there we go. Share entire screen. That's what we
Damn
want.
it.
Ah, it was a button. So stop sharing, start sharing again. We're going to get it. I want to see Steve's slides. And then I grant.
Oh, sorry. Go ahead.
Grant. Share entire screen. Now you should be able to tab over. Hey, yay.
Okay. So this is our goal. We want to build as much information about terrestrial fiber infrastructure as there is about undersea cable infrastructure. And a lot of our work is working with regulators and with operators and changing norms about sharing. And the interesting thing is that there are lots of network operators that share maps of their fiber optic infrastructure, and I think we can see an example here. This is Broadband Infraco in South Africa, and it's great. I mean, this is a very positive sign of an operator that shares not only the roots of their network but the access points, the points of presence. But this is essentially, it's a JPEG image, right? And a JPEG image is not very useful if you're trying to combine that data with other sources, and to integrate it, say, into a GIS system. And so what we've been developing are some tools to help you get from here into the structured data format that is the Open Fiber Data Standard. So, and first of all, I mean, one of the easiest things you can do is actually import that image as an overlay into Google Earth. And so I can take, for instance, this is a map that's publicly available of BTCL in Bangladesh. That's their national fiber optic backbone. Again, it's a PNG image and a little frustrating, as a standalone image. But if I import that into Google Earth as an overlay, then I can stretch that map out over Google Earth and align the map with the borders of Bangladesh and begin to actually then trace that network. And it's a little painstaking to do. It may be a few hours of your time to do it, but that you can actually then begin to identify the points of presence on the network and the routes and save that as a KML file. Now that's a big step forward, being able to have a KML file instead of a PNG image. But sadly, I mean, I don't know why Google did this. When they built the KML standard, they thought we won't need any metadata. And so, you have, I think, essentially two fields, a name and a description that you can embed into KML. And so it's not really good for structured data. So to go the next step, in order to take that KML file that you've built, that you've traced of this map, we built another tool, which is an online converter. It's also Python code that you can use at the command line. But I can take a KML file from any source and convert it into the Open Fiber Data Standard. So in this case, I'm actually going to take one, a little more robust example. This is Grid Online. It's the fiber optic network in Namibia. Run by Namibia Power, and they happen to offer a downloadable KML file that that you can save and then upload to this KML to OFDS converter. And as you upload it, you can begin to add metadata about the network. You can describe its status. An important distinction in fiber operators is whether you're leasing that capacity or you're the actual owner of the network. And so in this case, the owner is Namibia Power, and Grid Online is the provider name. And this is a very modest amount of meta information. We'll get to how you add more meta information shortly. And there are a number of other options for processing KML because people do the wackiest things with KML in terms of structuring data. And that's it, really. It parses the KML, breaking it up into individual routes and points of presence, and converts it into the structured data format that we call the Open Fiber Data Standard. Now, once it's exported, you have a JSON file and a couple of GeoJSON files. GeoJSON being an IETF standard for describing structured geographic data. And the conversion, you can see there, it gives you a little proof of concept there that the conversion has gone okay. And I can download that zip file of those files into my download directory. And now we can go to the next step. Having the structured data is actually imported into a GIS system. And in order to do that, we've built a plugin for QGIS, which is arguably the most popular open source GIS tool available. It's called OFDS Studio. It's available in the plugin library. It's like 2 clicks to install it as a plugin. And once you install it, you can instantly create these data structures that you see on the left-hand side here, which capture rich information about the points of presence and routes on the network. And I can take that that KML file that I've downloaded, which I need to unpack, but hang on. Hopefully, sorry, give me 1 second here. I will just unpack it. Okay. I can import that that JSON file, and suddenly you have a full GIS system that captures fiber routes and points of presence. And now in those points of presence, for instance, I can begin to then add richer data about those about the individual services available at points of presence, the kinds of infrastructure, the kind of availability, a range of issues related to what kind of services are available at that point of presence. Similarly, when it comes to the individual spans, you can capture information such as, is it underground infrastructure? What ITU standard is the fiber optic cable? How many strands of fiber are on that network? And with the goal of creating a robust GIS system for managing data about any terrestrial fiber optic network. And the advantage of doing this is once everyone's speaking the same language about fiber optic networks, you can begin to integrate that data together. You can do benchmarking. You can develop one tool that works for one regulator will work for every regulator everywhere in terms of analyzing and using a common language for describing infrastructure. We place a lot of emphasis, or there is a lot of emphasis internationally from the ITU and from other organizations about the resilience of submarine cable infrastructure. And we've missed half of the discussion by not having as in-depth and robust a discussion about terrestrial fiber optic infrastructure. It's the two pieces together that actually tells us how resilient the global internet is. And so I invite you to explore some of these tools, to try it out yourself. And one of the great things is you can contribute to building a map. And the map is here. It is a sparsely populated map at the moment, but all of the data for this map is stored in a GitHub repository, and you're welcome to build your own map of where you particularly live or a place that you're particularly interested in, submit it as a pull request to the repository, and dynamically update a global crowdsourced map of fiber optic infrastructure. Thank you.
I'm first in the queue, so we have to like share this. And yeah, people are jumping in. This is awesome just to start. I think that's a really, really cool effort. I guess the core question is why just fiber? Sort of, you can imagine any internet link being relevant down here. Is it just that fiber is less churny than other tech? Is it that, I guess, yeah, why just fiber?
Well, in my opinion, not just fiber, but fiber is a great place to start. It's really it's the foundation. And so we hope to build out from there. At the moment, we only, the standard only covers national and middle mile fiber infrastructure. This year, we intend to extend it to fiber to FTTX networks, fiber passive infrastructure, possibly to undersea cables. But it's not limited to fiber as a technology in any way. I mean, another interesting source of open data is tower infrastructure. And again, there are norms here that just don't track across different countries. So for instance, Canada, you can download a CSV file of every tower, every radio, every antenna, every altitude, azimuth. All of that data is public data downloadable, to your desktop. The same with the Netherlands and Switzerland. They make that data available, but other countries make, it's absolutely out of the question that you would share. So a lot of the conversations we're having about the Open Fiber Data Standard is really just about norming and kind of creating a conversation where sharing more information becomes comfortable for everyone.
Leandro?
Hi, thank you, Steve, and also thank you for your question before, Curtis, because it relates to my experience. In the GIFINET community network, like more than 20 years on this, we started with lots of community networks in Spain, and suddenly Ramon came with an implementation of a mapping system and some other tools, and people said, wow, that's wonderful. And I think one of the key successes of GIFINET was to provide the tools for mapping the network in an interoperable way, which was a requirement to create a community network, kind of umbrella organization for smaller community networks in villages. But when fiber came, people were reluctant to share the mapping of them because they were have fear that someone will come and cut the free fiber or something like that. But in the recent years, we found that with the explosion of commercial interest on fiber, we had controversies, even lawsuits with maintainers who claimed that the fiber network was theirs, even though it was paid by the community, and even they got tax benefits from donating that infrastructure to the common good. And now the GIFINET Foundation is in these lawsuits, and they see the importance of making public claims about who invested, who deployed a network, that the network belongs to someone and not to someone else. So this open data is critical for the survival of the foundation even, and to claim this is mine, not yours. But in general, I think there is reluctance to share this information. And I mean, in general terms, I would think about the idea of the requirement for transparency or accountability on infrastructure that somehow is public. And I mean, connected to the existence of an interoperable way of representing this information, that is the, I don't know, legal regulatory requirement, not just to be cool, but to be to have a requirement to be transparent, to be accountable, to be responsible for those deployments. I don't know if you've explored that area, and to what extent this data standard is also an instrument to enable this kind of required national or regional transparency about infrastructure investment or ownership or whatever on fiber networks or other type of public infrastructures in a way.
The issue of transparency is one of the hardest things we deal with in our advocacy for the open fiber data standard. I mean, we see the same thing in undersea cables, that, you know, we can't share maps of detailed maps of undersea cables because of threat actors. So to begin with, our focus is on, well, okay, that we respect your position, but let's at least agree to use a common language for describing the infrastructure. And while we're using that common language, we can begin to have a conversation about how this information should be shared. Maybe much of it shouldn't be public. Maybe it should be available to the regulator or to licensed operators or to researchers under certain conditions. Those issues, I think, are going to be negotiated nationally, and we may see different norms of sharing emerge in different countries. And we don't preach in terms of what's correct here, but we do think it's that there's a missing conversation here about what can be made available and to who.
All right, last up we have John.
Yeah, I'm John Levine. I think you just answered my question. But first, I think this is great. I mean, I believe there are 2 fibers running down my street, and I know who owns one of them, but I don't know who owns the other one. You know, and having clearer maps would be good. Yeah, but I was kind of. But the issue obviously is that the maps also tell the bad guys where to cut. You know, and I'm wondering if you've sort of some sort of framework about, you know, which ones are sensitive enough that you might want to hide where they are versus the one that runs down my street where nobody cares.
I think there are 2 answers to that. One is, I think there's an important conversation about bad actors and the dangers of making that information available versus the dangers of not making that information available.
There's no question that there's real benefits here, you know, so
but
we're balancing.
Yeah, my point being that, you know, in the largest operator in Nigeria and Ghana, MTN, report over 10,000 fiber cuts a year. And, you know, it's like Hanlon's razor, never ascribe to malice that which can be explained by incompetence. You know, most of these cuts are actually accidental. And if there was more available public data, they would actually experience less disruptions rather than more disruptions to the bad actors.
Like the crooks might know that that's fiber rather than copper, so it's not worth anything, that kind of stuff.
No, I think it's just a lot of civil works that are happening without any sort of coordination.
Okay.
Yeah.
Yeah, I'm gonna have a little sidebar with Steve afterwards because I'm fundamentally confused about why bad actors cut fiber. Like as a structure, like especially international fiber, there's other routes. I don't like.
Yeah, no, from what I know, I think you're right that it's mostly like, huh, what?
Yeah.
You know, and particularly, you know, and I know that certainly in where I've seen places where there's signs on the pole that says this is fiber, it's not copper. You know.
Mm-hmm.
Yeah.
All right, cool. Thanks, Steve. And last up, we have Leandro. The clicker should work.
Do you have the timer?
You do. I mean, we have 25 minutes, so you're going to run us out. I'll start the timer, though. It'll be 20 minutes.
Okay, so thank you very much. I'm Leandro Navarro. I used to be a professor at UBC, but I took freedom from the some obligations. So as Curtis said before, I took participatory action research in a strict manner, and now I'm more like part of different communities. One of them is UBC. We have an NGO at UBC where we do something related to action research, which is called service learning. We work with students that because the UBC has a fund for cooperation for development projects, and then every year or every 6 months there are projects in which students volunteer to apply their learnings into the field, into practical examples like connecting schools, hospitals, communities in different places, sometimes locally, but most of the time in the global south through counterpart organizations which facilitate this exchange. The students go and try to help, but also they learn a lot from those experiences. And we support that from different initiatives. Also, the Catalan chapter of the Internet Society, we support these initiatives, and we apply for the Beyond the Net program, in which we get support for buying equipment. UPC tends to pay the trips, and we have also the e-reuse initiative, in which we work with social enterprises who collect devices and for reuse. Devices can be routers, but antennas, point-to-point links, and user devices as well. Because without a user device, without a mobile phone or a laptop, we cannot really connect to the internet. And this is field work. And in fact, for instance, Mireia it's an activist who was involved in the e-reuse initiative, in the reuse of electronic devices, and she started a PhD after that, and then she finished the PhD, and now she's back to the activist groups. Eduardo and Viviana, they belong to two communities in Argentina, which one is a social enterprise, the other one is a university that also has a refurbishment lab, and they provide connectivity and devices for students. So, well, this is the second presentation, I think, about an internet draft that was adopted in the previous meeting by the GAIA group. This presentation is similar to the previous one, so I'm going to skip a lot of already presented details. In the previous meeting, we discussed that we use the term digital sovereignty in the sense that communities that have devices, connectivity, and so forth, they want to take their own decisions, let's say, but we found out that sovereignty is more and more used in a national environment. So we translated that into digital autonomy, or autonomy, the concept of being able to decide and choose yourself and not depend on a third party, an external party. And also, all these initiatives have to do with not just passively use the internet, but typically what it will come as kind of the concept of meaningful use, which depends on who is defining it. It's a bit different, but there are commonalities in it. There's also a new, feedback in the GAIA list, so that we try to incorporate it into the draft, and discussion about security aspects, and a bit some tweaks to the document. So, we tend to think that community network is something that you deploy and then you use it for forever. But in fact, it is not the case. I mean, devices have a lifetime, and they need to be repaired, replaced, relocated because the users are somewhere else, and so forth. So it's a kind of dynamic environment. And in our student experiences with partnerships with Global South communities, we find that sometimes you deploy, you know how to deploy, you know how to repair, you know how to set up a network infrastructure, but then when you come back the following year, you realize what happened in the meanwhile. You suspect that from the communications, but when you go back and 1 year or 6 months later, you find how things are. So there is a big need, and we have increased that effort over the years in supporting communities to have repair capacity and being able to manage this kind of pool of devices which are the basis for their network infrastructures and connectivity services. So yeah, I mean, deployment, setting up a network, providing coverage it's a requirement, but it's not enough. You need to have all the elements in the chain working all the time, which means you need to know how to procure, repair, reset, update, whatever, all the elements of the infrastructure. And also, of course, make sure that not just you provide the technical means, but also you need to also help the community to understand how to use that thing in a constructive manner. So the document, I recommend you to read it if you're interested. It's hard to cover all the pages in one presentation. It describes some principles, also some operational practice, some examples, some practical examples that we've worked with them, and in which any device becomes part of the connectivity infrastructure. And well, there is a focus on something specific, and we are not really trying to define any protocol in particular. In the section 7, you will find a description of the different communities that we have used for developing the document, in which in all of them, there is a component of connectivity, a component of network and or user devices, or both, with different particularities, different regions involved, which means we can identify things which are in common, things which are different, things which are the same idea but implemented differently and in different places. And that covers Africa, Latin America, and Europe, Spain mostly. So in the document, you will find some definitions about what is meaningful connectivity, digital autonomy, what we call circular device management, which is not just like an environmental thing, it's also like devices can be reused by the same or different people over a long lifetime if there is local capacity to repair and refurbish and upgrade these devices. And a common interesting thing is that connects very well with community networks is that in all these cases, there is a community ownership of the devices. There is a legal term called comodatum for that. It's Roman law, so it is not invented yesterday, and in which well, people want to use the devices, not own the devices. Owning devices is another thing. It's like imagine like a long-term library of things. So you get a loan, a device that belongs to the community. You're supposed to return it for reuse or for recycling because it's not yours completely. It was given by the community to you. Well, if you're a student in the university, when you finish your studies, maybe you should return it. Or if you are in a community, as long as you live there and you use it for whatever the community program, it's yours in a way. And then, well, in the document, you will see several core principles that are typically in these operational experiences we include. I won't read it all, but you can see For instance, I said one of the typical examples is this idea of collective access models, which applies for the connectivity, an inclusive model for accessing the network, but also an inclusive model to accessing devices, because as I said, without devices, connectivity doesn't mean anything. We don't have any sense in our brains to read IP packets. And again, I mean, all the local capacities, which sometimes, as it happens with community networks, when the communities grow, they need to formalize themselves better. And also, some of the volunteers that typically learn by doing might end up into permanent jobs or part-time jobs, which are also an element for economic sustainability of the local network. And of course, there's a governance element and so forth. Not only principles, but also practices. I mean, there are some typical tasks that happen in these communities. Like you see here the words that we use. I mean, repair, training, capacity building, providing programs to orient connectivity to certain benefits or uses, collective decisions, ways at some point, ways to provide transparency, accountability about. I mean, like accounting books in a medium-sized NGO or something like that. You need to prove you are managing your resources properly. For reuse, particularly, it's very important to make sure that data synthesization is done correctly. Otherwise, people fear that my files will appear somewhere else or by someone else can access my personal documents and some other aspects. So this is collected in the document. Regarding meaningful use, there were some comments in the list, and we incorporated in the draft not just the words, but also the examples. So we collected from the different communities that we're working with them examples of what is the meaningful use they were targeting or they achieved through this idea of managing devices, network, and user devices as commons. In the document, there's a connection, but it hasn't changed much related to, well, I mean, the deviceability has to do with the right of participate and benefit from the internet. Autonomy means that you need to be able to repair your own devices, find the spare parts, and so forth. In Global South projects, when we go the following year, we also take the e-waste that is there back to home because recycling capabilities in certain places are not really there. Regarding security, of course, is not only the security, the use of the internet, which means training and support for community members for safe practices and to avoid traps or things on the internet. But also the quality of the process in managing these devices and reusing them in different ways, like quality checks, sanitization, inventory management, which allow a small scale initiative to become larger and to work for the size of their community. And well, different aspects related to sustainability as well, they are discussed in the document. Well, this is not different from maybe the previous presentation in the last IETF. Why is connected to the GAIA research? If you have any question, we can discuss. It also includes a bit of more in the newest draft. It goes more in detail into possible open research questions, things that deserve some extra thoughts. And well, the last point is well, this sentence in italics is kind of the last sentence in the document, which I think is a good conclusion. It's understanding how device ecosystems interact with connectivity infrastructure, community participation, and sustainability objectives might contribute to a more resilient and inclusive internet connectivity models. But it's not the whole document, it's just a sentence. So my question to you is, what do you think needs to be included before the document, let's say, closes by just rereading, I found some small things like alphabetical ordering of definitions and a few typos. But other than that, from our perspective, we find it is quite mature. And then if that works, let's say, how do we move forward and adopt? Which is the process of adoption? It's something good to know. So, but if in the end, this is a kind of overview of the latest iteration on the document, and glad to share and discuss with you whatever you want to comment. Thank you. Oh yeah, one second is I just included in the document the acknowledgements to the funders and the supporters and the people who contributed effort into this, which overall it takes more than 10 years of different activities. This is the example, for instance, of a community center in Argentina, in Rosario. This is the refurbishment lab in Tau, also in Argentina. This is a program that the National University of La Plata has, in which students that have not enough resources, they get the laptops. This is a few weeks ago. There was a public event where 200 to 300 students got laptops from the program. These laptops were prepared in that warehouse where you can see they are very organized in sections and processes. And at the same time, in the university, they run a computer repair program and refurbishment program to train not just the university students and technicians, but also other actors in the community, other NGOs that also support vulnerable population, or even citizens who want to buy second-hand device instead of a new one. And then with that payment, pay the workers in this social inclusion NGO, and also provide resources for the initiative to be able to donate devices for students as well. So thank you.
All right. So join up in the queue if you have questions. I am first in the queue, which, just as some context, GAIA is not an RFC machine. We've produced one RFC in the entirety of GAIA's operation, which is, I think, nearing 10 years, if not at that. I think it was, Arjuna circa 2016-ish sounds right. Maybe before that, it was in grad school, right? But anyway, so we're really excited to kind of step back into that space. And the chairs have been talking about updating the old RFC. But I think the core question really is this the appropriate place for this? And, you used to be chair, and so this is a home community. But Sustain is, I think, next door. Should it be at Sustain, given the focus? Or I think you've done a really good job contextualizing it within GAIA, like the importance of this space for connectivity and for getting technology out to these areas is really critical. But it has a big sustainability focus. Have you talked to them? What do you think about that? Why is this the right home base?
Yeah, but yeah, as I said, if we produce one RFC, I think we can produce a second one. And also, the tools are quite different from previously. So for me, it was a learning exercise how to use the tools to produce a document, and then it compiles and generates the text, XML, HTML, and PDF outputs of it. So it seems it works. And regarding the binding to GAIA and to Sustain, of course, it has an implication for sustainability, but I think the main focus is, this is there. For instance, when we use circular as a concept, circularity is a kind of strange word, because an apple is circular. You have a tree, you eat it, there are seeds, and there's a new apple tree and comes back and sounds like a circular. But a computer device, a router, is not circular by any means. It's spiral at most, but never circular. You do not recover a router by putting it into the ground and you get another router out of it. So, is this trade-off that if you end up providing internet access for everyone, how how do you deal with the environmental implications of producing so many devices? I don't know. So it's there, but we also use the term circular in a sense of use. In community networks, it's typical that if the population is somewhere else, you might bring one access point, one link, and put it somewhere else to expand coverage in a new area. And also, if you do that, well, those guys need devices to access, to use that connectivity. So we also look at that, routers, switches have a very long lifetime. Laptops, medium, mobile phones, very short. But still they are reusable. So if the devices belong to the community, it makes sense that you can recirculate them to other people. So I think that the main point of the document is documenting these practices in which communities are autonomous enough to procure, maintain, reallocate, and even in some cases recycled these devices to recover parts. And this kind of circular management of all the infrastructure is a requirement for these community networks to be, of course, sustainable in environmental terms, but also sustain over time, be able to evolve, maintain the infrastructure, because as I said before, when we do these collaboration projects, we find that typically there is lack of money to deploy a network, but also there's lack of money and skills to maintain it over the long time and to deliver quality of service. We were discussing before that some people might say, well, use the cloud because it's stable. So if we can manage to have networks which depend on local technicians, local decision makers, everything would be more like sustaining in the long term. And I think this the major dimension of the work is community networking or the GAIA environment.
Yeah, I think that's correct. And really, there is overlap just with GAIA and Sustain. And so we got to put them on the list so people can go to both instead of having them running concurrently as we are at this IETF. And that's on me. So maybe in the future, there's just discussions to have with them. But that's a good answer to me. We have Ben.
Hi, thank you. Ben Roberts. I'm from Kenya, so representing the global south, I suppose. Good work you're doing. You're asking your questions, what, from a research point of view, what can really help this? In schools in Kenya, nearly every single device is a recycled device. It's generally, there have been companies operating for years that have been recycling desktop PCs coming out of call centers or something, laptops as well. So everything is generally recycled. Windows 10 came out in 2015 and is now in its sunset phase. So nearly most devices would be Windows 10, quite a lot of Windows 8. So they won't find much any other operating systems. They'd be the main operating systems of devices. In terms of Linux devices, almost nothing, but they're going to be the two predominant ones. Almost none will be Windows 11. So I agree with you about local technicians being able to repair and recycle and get boards. I see this. There's some friends of mine in Bungoma County who do exactly this. They go around, collect them all up, and then they fix them up, and then the broken ones, and then give some back to the schools, and then give the other ones to new schools to circulate them. But I think there's a lack of certainly lack of technical capacity around knowing then what open source OS you can use instead that will actually work and be supported. So if you say, okay, if you've got this much RAM and this CPU, what is the best version of Linux to use that is still going to carry on being supported for security fixes. So I think some research around what operating systems are out there in those recycled devices is absolutely key and can be done quite easily. and then also best practices and dissemination of those best practices, what OS to use and how to do that, right? If you've got a computer and it's a brick, how do you install a version? We don't have CDs anymore, so so teaching people capacity building on how to get a working OS onto those to make them actually have a ongoing life, since Windows and Microsoft have withdrawn from the conversation.
Yeah. I mean, I subscribe to all your points. In fact, this slide I think reflects a lot of the working ingredients of an operational community infrastructure for, in this case, university students in La Plata. Yeah, if you don't have all these ingredients, your network is fragile. It works as long as the funder or the initial volunteers or guys from outside decided to do. And typically people don't touch it, because if the white guys from the north are not there, if they do something wrong, it would spoil things. So better degraded than nothing. So yeah, we find all these critical, so that whatever form of community networks for school, for a certain community, for a health center, relies on all these elements. You see on the top left, you not only see piles of devices which are moved as they are processed in the place, but also you find some things which are not a computer. They are like special tools for data wiping, for other processing of testing whatever components, which improve the quality of the refurbishment process. So these guys are very experimented, and I didn't discuss, but for instance, with all these initiatives, we are developing open source tools in which we try to incorporate their processes into the tool, so that they can do all this process in a more efficient manner. So when you move one device that has been already inspected to the other pile, we can record that into the inventory system of the factory, let's say of the refurbishment factory. Without this, people doesn't know which operating system would work in that new desktop or laptop computer. We try to install Linux devices in some schools, well, it was an interesting experience, let's say. In one case, it was funny. It said, well, do that if you want, and find out that the laptop, how slow it will be when it runs Windows. And they tried, and then they say, okay, maybe Linux is not that bad at the end. But it's a lot of knowledge that it's granted in the IETF, but it's not in the community. So this is also work has to be done. Is meaningful access means not only knowing how to use the internet, but also how to maintain the infrastructure. But well, I mean, I encourage you to read the document, because I would be able to talk for too long. But I think the point is made. Thank you.
All right, we are at time. Thank you all for coming to GAIA. See you all in San Francisco, I hope. If you're interested in talking, please reach out to us. And of course, this is active working group RFC activity. So if you're interested, the mailing list is the place for that. Make sure to join that, where the discussion will continue. So thank you all. See you around. Oh, I gotta turn it off.